But we basically did a couple of trig graphs in between the trig and this section of trig. Obviously, it doesn't matter the way you watched it, if it was trig 1, 2, 3, 4, 5, 6, etc., and then the graphs, or the graphs first. It depends upon how you're doing it in class, basically. But now, what we're going to do is we're now going to look at, so far, we've spoken about angles, okay? And if you remember, I just want to draw a quick thing. In here, these angles are acute. In other words, the angle theta is less than or equal to 90 degrees, greater than or equal to 0. So what we're saying is that any angle between 0 and 90, any angle between 0 and 90 falls in that area. Because remember, now we're going to be drawing it as a graph. So we're going to have x and we're going to have y up there, and we're going to have theta as our measurement of our angle coming up like that, right? So we're now going to be linking in, once again, we're going to be linking in the Pythagoras and the angles, etc., like the trig equations, okay? But we're going to be looking at angles that are greater than 90. So we're going to be looking in at angles that are 90 and beyond now, right? Because a lot of angles are measured that way. So let's just redraw this graph neatly. Over here, can you see x and y? That's positive and positive, right? Which means that any arm or ray that I draw that way up to point P has got coordinates x and y, right? That length is y, this length is x, that's theta. Now in this area here, we call this quadrant 1. They usually use Roman numerals quadrant 2, quadrant 3, and quadrant 4, all right? What we need to see is that x here is minus and y here is minus. Okay. Now we're going to look, because when we are doing trig, we're trying to get everything to be acute. Our target is for all angles to be acute. Okay. In order to do that, we're going to apply something called a reduction formula. Okay? Don't worry about it at this stage. We're going to reduce the angle to just having an acute angle. Okay? Now, before we get into that, let's just go back up and look at, if we were to put into our calculator, right? If we were to put in sine of 30, cos and tan of 30, okay? We would get all the sine, cos, and tan would be positive answers, wouldn't they? Now let's take it this side, all right? Let's say we've got an angle over there. Just have a look here. That height there is y. This length here is minus x, isn't it? Have a look, okay? The sine, let's call that h there, right? So the sine of alpha in second quadrant, the sine of alpha is opposite, is y over h. Now the hypotenuse in all these cases here will be positive. Why? Because we're going to square it. Let us take the bottom one here, right? Where I've got a minus y and a minus x. If I square those and take the square root, my hypotenuse, usually called r, okay, is going to be positive. The length is always positive, okay? You can't have a negative length of a line. You can have a negative length on the x or the y-axis, but the line itself always turns out to be a positive. So what it's saying to us is it's saying to us that in each quadrant, the sine, the cos, and the tan, they're not always going to be positive. Because in this quadrant over here, okay, we get, let's have a look, we get sine is y over h. It's positive. Cos in this quadrant is negative. Tan in this quadrant is opposite over it's negative. And as we go around, so we find that in each quadrant, if there's an angle in that quadrant, its signs, the trig functions, can be positive or negative. They're going to change. Okay? If you look at the graphs, just very quickly, remember I said please learn the graphs? If you look at the graphs, all right, here's the standard sine graph, right? There's 90, there's 180, there's 270, there is 360 degrees. Let's move up and put in a cos graph just underneath it to the same scale. Okay? Remember the cos graph did this, didn't it? Okay, whoops. Put you here and you here. We came down, 0, up, like so, like that, correct? Okay, at 360. 270, 180, and 90 degrees. Can you see this here, green, this is actually quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Because the angles are there. Let's have a look. Where is 150 degrees? Well, if you drew it, you'd go around to 150 that way. You would actually draw this, wouldn't you? You'd say, okay, up to 150 would be 150, which means that's a 30 degree left on that side, isn't it? 180 minus 150. So that angle would be in quadrant 2. Now if you go and look, it's in that range here. This is quadrant 2, from there to there. Correct? Right? This is why I say it's very important to know your graphs, because it makes it so quick to see where things are negative and positive. So over there, the sign, okay, is going to be positive and positive, negative and negative. Here it's going to be plus, minus, minus, plus. Which brings us to the overall diagram, which is usually referred to as cost. Okay? Okay. Okay. What we do is, it's a diagram like that, where we have, I remember it as all stations to Cape Town. Okay? Others remember it as CAST. Just get it into your memory as to which it is, and then the graph associated with it, x, minus y. The standard Cartesian plane applies here too. Right, so what does it mean? It means that they are all positive here. Sine is positive, tan is positive, and cosine is positive. Everything else is negative. We've only identified the positive ones, okay? So therefore, if you look at it, you've now got those quadrants, right? And we now know that in quadrant 2, for example, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? We can now say, right, any angle I drew up there, I know that the sine, the cos, and the tan are all positive of that angle there. But what if I draw an angle over here? Okay. I have to change this from that angle to an acute angle. Okay. This quadrant here, this is, let us say, 150 degrees. Therefore, theta is going to be 30 degrees, isn't it? How did I get that? How did we get that? We said, well, this is the 180 marker, which means that if it's in quadrant 2, if you're in quadrant 2, the angle is 180 minus theta, all right? Where then I say, okay, 180 minus theta would be 150 degrees. Therefore, theta, the remaining acute angle, think of it like that, okay, is going to be equal to, right, theta is going to be 30 degrees. Okay, so in there, we know that the corresponding acute angle, this quadrant, then we can call our 180 minus theta quadrant. Okay, well, what happens next? Okay, let's say we draw an angle over here. And that angle is, let's say, 215 degrees. All right? The angle I'm looking for is that one. Okay? And you'll see that when we solve these, we draw them. Okay? We make little sketches where it is, just to keep reinforcing and anchoring ourselves back to basics. That's the critical here. Go back to the basics, because then you don't have to remember a whole lot of stuff while you're trying to sort out the answer, do you? Okay? So what do we say? We say, right, that is theta there is going to be, well, 215, how am I going to find? This is the 180 plus theta. So theta there is going to be how much? Well, it's going to be 180. Now this is where people go. 180 plus theta must be equal to 215. Kevin goes and puts 218. Okay, probably his writing. 215, right? 180 plus that must be the 215 that I drew. Can you see why it's critical to get a handle on drawing these things? Very important. So we say 180, therefore 215 minus 180 is equal to, that's 35 degrees there. So now we're able to break it down. And in over here, the last quadrant, okay, if we draw an angle, there's our actual angle, call it 320 degrees. The angle we look for here is this guy. This angle here is going to be 40 degrees. This we call the 360 minus theta. Okay? You're not going to use 270 plus or 270 minus. Seldom 90 plus or 90 minus. Okay? Those are complementary angles that we'll get to in a different scenario. What it means is that if we are given an angle, we apply a set of reduction formula to it, okay? Where we are going to, first of all, say where is it? Then we apply a reduction to reduce it to the acute angle. You actually don't even need, you can work it out yourself, all right? In actual fact, what we do is we say, right, say we have cosine, we just change it, you know what I'm doing, changing it always back to my base color, okay, cos of 125, okay, or cos 125 degrees, okay. I prefer, personally, not to have the brackets there, okay, cos of 125 degrees. So what do? Step one, sketch it quickly. Sketch where it is. So 125, I know, is somewhere there, and that's my 125, okay? Then we say, sketch where it is. Step two, identify the relevant reduction formula. In other words, this is our 180 minus theta, 180 plus theta. That's theta. You don't do anything there. Right? So it's in Q2, which means that the formula is 180 minus theta. All right? So therefore, we say, okay, step 3, find theta. Okay? What is theta going to be? Well, let's look. We say, okay, 180 minus theta must be equal to 125. Okay? This is our reduction formula. And this is the angle that we're trying to reduce. Okay? Therefore, minus theta is 125 minus 180. Theta is going to turn out to be 45. Okay? Sorry, 135. Okay? Let's just change it to 135, if you don't mind. And it becomes 135 is 45 degrees. Right? I've just used this because it's a special angle. All right? But the same would apply if it wasn't. We'll do a few more with them. So we say theta is 145. Then step 4. Step 4 is write down in the reduction formula. So I've now got cos of 180 minus 45. Remember, we've now taken cos of 135 degrees. It's equal to that, isn't it? It's equal. It's the same thing. All I've done is I've changed it to be in the correct quadrant. Right? Then the next step is I say, right, check the sine. Step 5, check the sine. Okay? In other words, ASTC. Okay? What do? I always actually, the moment I've drawn it, I go, I wished it wouldn't do that. ASTC. I always look. So the only one that is positive there is sine. So now I can say, right, that is then going to be equal to minus cos of 45 degrees. Okay? So we've reduced it to check the sine, okay? And it's minus in there, and it becomes just the cos of that angle over there. Okay? We'll do some examples in a few moments. But you can see what we're doing here. Okay? We are just looking at it to reduce it down to always the acute angle. Okay, let's go through this one, all right, shall we? Tan of 290 degrees. Tan of 290 degrees. Okay, step 1. Just make a quick sketch. Where is that? That is 270, so it must be over here. There's my 290 degrees, right? So I say ASTC. I look at my quadrant. Well, let's go through the steps. Step 1 is that. Step 2 is, let's see which one we need. This is the 360 minus. Therefore, tan of 290 degrees is equal to the tan of 360 minus theta. Okay? What is theta? All right, so we can say 360 minus theta must be equal to 290. Therefore, minus theta is 290 minus 360. I know this is a very tortuous way of doing it, but you'll very quickly start saying, okay, it's 360 minus 290 is equal to 70 degrees. Okay? You can even see it from there. It takes 290 is 70 degrees, right? So therefore, that is, theta is that. So now we write it in the form. We say tan of 290 degrees is the same thing as tan of 360 minus 70 degrees. All right? Therefore, now, next step, check the sine. AST, tangent is negative, so it's the negative tan of 70 degrees. All right? So here's our acute angles that we are targeting, right? To reduce it down to the acute angle. Right? So then basically you put in your calculator. Now let's have a look. Let's look up, okay? Let's look it up, shall we? What is the minus tan of 70 degrees? Okay? I'm going to just look up something here for a second, okay? We got here minus tan of 70 degrees. I am going to look up the tan of minus 70 degrees and the tangent of 290 degrees. Just have a look here. Okay? Okay. All clear? Minus 1 times tan of 70 degrees is minus 2.7475. Let's look up the tangent of minus 70. Tan minus 70 is minus 2.7475. Let's look up tan of 290 is minus 2,7475. Why? Because it's the same angle, isn't it? Let's just look. Draw a line of 290 degrees. Boom. Remember I said you take your protractor, the big circle one, and go all the way around to 290. There it is. Okay. The other way I could have done it is I could have drawn an angle at minus 70 degrees there. So I go minus 70 and I work out the tan. The other thing would be to apply the reduction formula, which gives me minus tan of an acute angle. They are all the same angle. Here's all we've done, is we've actually calculated the tangent of exactly the same angle over there. Right? Here, for example, all right, the examples here we've got, let's have a look. They say for us, well, they've given us this, okay? They have given us this. Sine of 30, okay, sorry, sine theta, okay, is equal to 5 over 13, and 90 degrees less than or equal to theta less than or equal to 270 degrees. What I need you to do here is I need you to see when they ask, and you'll see it clearly, they ask it in this form. Can you see there's a and? There's two pieces of separate information here. Two distinct pieces of information. So what are we going to do? First of all, we always get the left-hand side, this one here, we get it into the form of, let's just go, come on, there we go. We get it into the form of a trig function equals something. Then we go to that and we say, okay. So step one, okay, is get the right-hand side data into standard form, which is trig function equals something. I'll show you in a sec. All right? Let me just take it like this, okay? Let's say we had 13 sine theta minus 5 equals 0. That is not just a trig function and a number. It's not a trig function equals a number. I have to only have sine, cos, or tan here. Can only be sine, cos, or tan. That function, sine, cos, tan. So therefore, I must get everything to the other side so that we get sine theta is equal to, that goes across, and then I divide by 13, 5 over 13. Okay? So get it into that form. Step 2. Check the sign of this. Is it positive or negative? Right? When you've got the sign of it, step 3, tick the relevant, tick the relevant quadrants. I'll show you now what I mean. What I do is I say, right, the sign here is, it's a plus. So I now look where A, S, T, C. I always put them in. Sign is positive. So it's there or there. There will always be two quadrants, okay? The sign is positive. If it was negative, I would have ticked quadrants 3 and 4, right? Just go through it step by step like this, and they're simple. I know students who just try and skip steps. That's where the mistakes come, okay? The reason they're only getting like 60 instead of 80 is because of skipping the steps. They try and memorize it because they think it's faster. It is not faster to do that. It's faster because you can quickly draw that, and you get into the habit of drawing it very fast. All right? So where are we now? All right? We've now got that situation. Okay? Okay, let me just get a new page. All right? And say, Okay, come on down. So tick the relevant quadrants, okay? That was that step. Let me just check. That was step 3. Step 4. Step 4. What is it? Step 4 is look at second piece of data. In other words, I'm going to say, which other quadrants? Okay? Can you see that in the previous example, okay, it said here, I'll go back, okay, to green, here, it said it is between 90 and 270. Let us go and tick those quadrants. Where is 90 to 270? There's 90, there's 270, which means tick, tick. Okay? So, check which other quadrants, all right, and what do? We tick those. Tick those quadrants, okay? Step 5. What's the next one? We say your angle is in the quadrant where there are 2 ticks. Okay? So step 5, your angle is in the quadrant where there are 2 ticks. Draw it in. Right. So now what do? We say, okay, we know that we had, in this case, let's just go back. We had the sine, it was tick, tick, and tick, tick down there. So let's just put them in. Tick, 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 and tick, tick. So we draw the angle in, all right? Like so. That is where this angle is, okay? Right, step 6. All right? I was going to carry on over here. Step 6, okay, is now label theta. Label theta and use the number. Remember the number? In this case, 5/13 to label the triangle. Okay, just a second. They want us to label the triangle. Hold on. They told us that the sine was equal to 5/13. Let's just have a look at this. Okay? They said sine of theta is 5/13, which means opposite over hypotenuse, which means the opposite is 5, that is 13. All right? Right. Now, the next step is step 7. All right? Step 7, okay, is what? Find length of other side. There'll be one side missing. This one here, your x-coordinate. It could be x or y. Usually an x, okay, but it doesn't matter. So how do we find that? Well, we use Pythagoras. Right? Pythagoras. Okay, now we say, okay, therefore, right, x squared is equal to 13 squared minus 5 squared is 144. Therefore, x is 12. Or minus 12. In this case, it's minus 12 because the coordinate there is minus 12, isn't it? What is the coordinate of this? It is got an x of minus 12 and a y of 5. There's my y, and there's my x. Okay? Just very straightforward, really not difficult. Okay? So, we've got, I chose the minus 12. This is where you have to use your nous. It's minus 12 because it's in that quadrant. The last part of these is they're going to say calculate, using this, calculate something. Let's say sine squared theta plus cos squared theta. You now know. I rearranged that to sine theta squared and cos theta squared. Sine theta was 5/13. Plus cos theta is going to be minus 12/13, isn't it? Adjacent over hypotenuse. And that breaks down to the following. It becomes 25/169 plus 144/169 is equal to 1. Okay? I know that one was longer than I intended it, but I wanted to get to the end of that section. As I say, I've done a few more, but please look at how I've done that. Reverse back, go through the steps, then try an easy one. And you'll see that the two, split the two, have a look, get it into the standard form, check the sign, tick, tick, and then the other piece of information, tick, tick, go to the two ticks, draw your angle in there, and then put in the information that you've got. Trust me, it's a foolproof method. It can't fail. You're going to use exactly the same set of steps right up till grade 12 with this. Okay? In the next section, we're going to go on with functions. Thanks for watching it, and I'm hoping that, that this part of the trig, the more advanced piece, is clear. And if not, please do some of the examples out of the test and exam prep session. Cheers, bye.